According to satellite data scientist Simon Proud, the eruption of Tonga Volcano that happened in January was pretty shocking and unlike anything ever seen before. It was clear, just from the initial images, that it's much bigger than anything we've seen in recent years, and probably in the satellite era, said Simon Proud. As the ash settled over the Pacific region in the days following the eruption, aerial surveys and satellite imagery started to reveal the volcano's catastrophic impact. Houses on the Tongan islands got wiped out. Other islands were covered in acidic ash and left flooded from a tsunami triggered by the powerful eruption. Now, today's video will explain why the Tonga volcano baffles scientists and also tell whether another large eruption is detected. Stay tuned and watch till the end to be more informed. While residents of Tonga strive to recover from the devastating volcanic explosion that smothered the Pacific island nation in ash and covered it with water, scientists are trying to understand the global effects of the eruption better. They already have the answer to one important question. Although it seemed to be the largest eruption in the world in 3 decades, the explosion of the Tonga volcano last month will probably not have a temporary cooling effect on the global climate, as some past enormous eruptions have. However, in the aftermath of the event, there may be short-term effects on weather in parts of the world and maybe minor disruptions in radio transmissions, including those used for global positioning systems. Further, the shockwave caused by the explosion and the unusual nature of the tsunamis it generated will have scientists studying the event for years. Moreover, tsunamis got detected in the Pacific, Atlantic, Caribbean, and Mediterranean. Not that we weren't aware of volcanic eruptions and tsunamis, said Laurie Dengler, an emeritus professor of geophysics at Humboldt State University in California. To witness it with the modern array of instruments we have is truly unprecedented. The explosion of the underwater volcano, which is formally called Hunga Tonga-hunga Hapea, rained hazardous ash over the area, including the Tongan capital Nuku'alofa, about 40 miles south. Also, the capital experienced a 4-foot tsunami, and elsewhere, higher wave heights got reported. The government referred to the eruption as an unprecedented disaster. However, the whole scope of the damage has been hard to determine, as the explosion greatly affected undersea telecommunications cables, and ash forced Tonga's airports to shut down. Beyond Tonga, the severity of the explosion was readily apparent. Satellite photos indicated a cloud of dirt, volcanic gases, rock, and water vapor several hundred miles in diameter, and a narrower plume of gas and debris soared about 20 miles into the atmosphere. Some volcanologists drew comparisons to the catastrophic explosion of Krakatoa in Indonesia in 1883 and to the recent enormous eruption of Mount Pinatubo in the Philippines in 1991. Pinatubo erupted for multiple days, sending around 20 million tons of sulfur dioxide gas into the upper atmosphere or stratosphere. There, the gas mixed with water to create aerosol particles that reflected and scattered some of the sun's rays, preventing them from reaching the surface. For many years, that had the effect of cooling the atmosphere by about half a degree Celsius. Besides, it's the mechanism of a controversial form of geoengineering, using planes or other means to continuously inject sulfur dioxide into the upper atmosphere to cool the planet intentionally. Shane Cronin, a volcanologist at the University of Auckland in New Zealand who has studied earlier volcanic eruptions, said the Tonga eruption was matching the power of Pinatubo at its peak. However, the eruption only lasted around 10 minutes. In addition, satellite sensors measured about 400,000 tons of sulfur dioxide reaching the stratosphere in the days that followed. The amount of SO2 released is much smaller than, say, Mount Pinatubo, said Michelle Manga, an earth science professor at the University of California in Berkeley. So unless the Tonga eruption resumes and continues at an equally strong level, it won't have a world cooling effect. However, this is considered very unlikely. Dr. Cronin stated the power of the eruption was somehow connected to its location, about 500 feet underwater. When magma or super hot molten rock hit seawater, the water instantly flashed into steam, expanding the explosion multiple times over. The water pressure would have dampened the explosion if it had been much more profound. The shallow depth created perfect, almost Goldilocks conditions, he said, to magnify the explosion. The blast generated a shockwave in the atmosphere that was one of the most unusual ever detected, said Corwin Wright, an atmospheric physicist at the University of Bath in England. Satellite readings indicated that the wave reached far beyond the stratosphere, as high as 60 miles up. Furthermore, it propagated worldwide at more than 600 miles an hour. We're seeing a really big wave, the biggest we've ever seen in the data we've been using for 20 years, Dr. Wright said. We've never seen anything that really covers the whole Earth like this, and certainly not from a volcano. The wave happened when the force of the blast displaced significant amounts of air outward and upward, high into the atmosphere. But then, gravity did its thing. Again it rose, and this up-down oscillation continued. As a result, a wave of alternating high and low pressure was created, and it moved outward from the blast source. According to Dr. Wright, even though the wave occurring high in the atmosphere, it may potentially have a short-term effect on weather patterns closer to the surface, perhaps indirectly by affecting the jet stream. We don't quite know, he said. We're looking to see what happens over the next few days. It could just sort of ripple through and not interact. Also, Dr. Wright said that because the wave was so high, it could also possibly have a negative effect on signals and radio transmissions from global positioning satellite systems. Additionally, the atmospheric pressure wave might have affected the unusual tsunamis that occurred. Tsunamis are produced by the rapid displacement of water, often by the movement of rock and soil. Enormous underwater faults can cause tsunamis when they move in an earthquake. Volcanoes can also cause tsunamis. In this case, the underwater blast and the volcano's crater's collapse may have led to that displacement. Or, one flank of the volcano may have unstabilized and collapsed with the same effect. Still, scientists said that they would only account for the local tsunami that inundated Tonga. Ordinarily, said Jared Fryer, an affiliate researcher at the University of Hawaii at Manoa, who initially worked at the Pacific Tsunami Warning Center, you'd expect that energy to decay away with distance. Even so, this event generated tsunamis of nearly the same size as the local one and over several hours in Japan, Chile, and the west coast of the United States, and even generated small tsunamis in other basins elsewhere globally. That's a sign that as it went through the atmosphere, the pressure wave may have affected the ocean, causing it to oscillate as well. It'll take some time of analyzing data to find out if this is what happened. Yep, some researchers have said it's a possible explanation. We know that the atmosphere and the ocean are coupled, said Dr. Dengler. And we see the tsunami in the Atlantic Ocean. It didn't go around the tip of South America to get there. The evidence is very clear that the pressure wave played a role. The question is how big a part. While many aspects of the eruption and its impact on Earth remain puzzling, what's clear is that scientists will be poring over the data from this event for many months and even years to come.